Hi and assalamualaikum. So for this video, we are from Group 5. We would like to present our group project on course numerical method. So my name is Dr. Timur Farid. My metric number is F220213. So here is my group mates. First is Nur Danisha, Nur Ashikin, Sharina, and Gabriel. Next is development. So we'll present about introduction, background, objective, problem statement, literature, methodology, calculation, and lastly is a discussion and conclusion. So for introduction, numerical method is estimation of solution to differential equation, optimization of problem, in large scale system that are commonly included in the world. So through this, we use a systematic algorithm and computing the procedure. So this field may include issue involved in linear system solution, numerical integration, root discovery, interpolation, differentiation, optimization, and differential equation. So this technique are a problem solving technique that used to find approximation for mathematical solution. So it typical difficult or impractical to solve using analytical procedure.
Hi, my name is Nurul Ashkim Zakaria and my matrix number is CF220215. So I will be presenting on the next slide, which is background study. So in this study, we decided to use the interpolation method in chapter 4 as the main topic for this project to identify the problem and solve the obtained data. And this study concentrated on the Lagrange interpolation, and moreover, Lagrange interpolation polynomial is like a math superior for understanding and estimating values between known points. Next is the objective of this project, which is firstly, it is to determine the suitable method for calculating the data in this project. Secondly, to employ Lagrange interpolation for resolving missing data in the dataset. And last one, to provide a comprehensive and accurate analysis of the interpolated values.
So for the problem statement, the data showed that annual precipitation or rainfall up was measured in year 2022 from February to July, and it states that the rainfall intensity for Sungai Kedil, Padang Police Station, the rainfall intensity data for May was missing in that month. Thus approximate the rainfall intensity in May by using Lagrange interpolating polynomial. So here is the table for month February. The rainfall intensity is 199. For March is 188. For April 243. June is 142 and July is 135. So we have to find missing data in May by using Lagrange interpolating polynomial.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurdanisha Irdina Bintu Maharizal. My matrix number is CF220203. I will explain about the literature review. Rainfall data is for manage water resources, modeling climate, and also assessing risk for disaster. Missing data is typical problem with rainfall datasets. Researchers use numerical interpolation technique to estimate and fill the missing data. Okay, next is the method for interpolation. We identify that we have two methods that we have studied, which is linear interpolation and polynomial interpolation. Linear interpolation is straightforward technique, makes assumption have linear connection, and also linear interpolation represent temporal and geographical fluctuation in the rainfall, while polynomial interpolation we can use two technique, which is Newton divided difference and also Lagrange interpolation. And our group decided to use Lagrange interpolation to find the missing data, and this is Lagrange formula interpolation.
Okay, so next part we will look at the calculation part. So what we know at this calculation part is, so we got the monthly precipitation recorded in February to July 2022. So if you can see a month here 2, 3, 4, 5, 6, and 7, but we don't have the month for May. Okay, so these are the rainfall intensity then we got here. So you can see this is the graph for the rainfall intensity. Okay, you see the curve here, bell shape. Okay, so now we go and find the missing data for the May month. So we want to find the rainfall intensity, how much is it. So it must be between 243 to 142. Okay, so it should be decreasing in the graph. Okay, so next we will look at the step by step how to find the missing data here. Okay, so in this part is the solution part. Just now we look at the table, right? So now the solution part, the first step is construct the data in table. Okay, first you need to construct the data in table, which means that you need to put a set for the column for the row for I, xi, and then the fxi. So we know is I is the 0, 1, 2, 3, 4, and then the xi is 2, 3, 4, 6, 7, and then the fx is the rainfall intensity. Okay, so this is step one. Step two, next is we're going to do is find the LO, the constant LO, L1, L2, L3, and L4 and X5 without its interacting polynomial in terms of X. So we insert the value of LO and then L1, then each value we insert X equals to 5, and then following by x1, x0, x1, 2, 3, and 4. So we get the value for each one. Okay, so the step 3 is the checking purpose. That means the sum of the all the constant LO until L4 must get equals to 1. So as checking purpose, so we got equals to 1. Then we evaluate the fx equation equals to p5, and then you find out that it is equals to 226.4 mm. So that is how we find the rainfall intensity for May. Okay, so the result we can say that based on the graph 4.1, the curve show decreasing from April to July 2022, which means with the missing data of May 2022. So therefore, it is proof that the monthly precipitation of rainfall intensity in May 2022 is 226.4. So we already proved that we see the graph there, curve there, it is decreasing. So the value should be between the April and June. So that's it.
So this is our methodology. We have four steps, which is first of all we need to collect data. Collect data from the rainfall in for rainfall intensity data in 5 months, and then we construct data, which is construct the data of the rainfall intensity in the table. Next, we need to find the Lagrange 0 until Lagrange 5 without its interacting polynomial in terms of x. And lastly, we need to evaluate fx equal to px. Thank you.
Next, my name is Sharita. Matrix number CF220129 will be talking about the discussion for this group project. The problem at hand involves the estimation of rainfall intensity for May 2022 at Sungai Kecil Padang Ulai Station. Given data from February to July, the approach employed is Lagrange interpolating polynomial, as outlined in the provided solution. Initially, the available rainfall intensity data is tabulated, with the absence of May data prompting the need for interpolation. The Lagrange polynomial then constructed and evaluated at x equal to 5 to approximate the missing value. The result, approximately to 2226.4 mm, is considered as the rainfall intensity for May 2022. The conclusion draws attention to a graph not included in the text, depicting a decreasing trend from April to July 2022, reinforcing the validity of the interpolated value for May. It is essential to recognize that interpolating assumes smooth transition transition between data points, and the accuracy of the result based on the assumption. Nevertheless, methods offer a reasonable estimation for the missing data based on available information, providing a valuable analytical tool for precipitation data analysis in this context. Last but not least, for the conclusion, in conclusion, the application of the Lagrange interpolating polynomial method to estimate the rainfall intensity for May 2002 at Sungai Kecil, Padang Police Station has proven to be a robust and effective analytical approach. The meticulous construction and evaluation of Lagrange polynomial have facilitated the approximation of the missing data point, yielding a value of approximately 226.4 mm. This estimation not only aligned with the observed graphical trend, highlighting a decreasing pattern from April to July 2022, but also provides a valuable insight into the dynamic of monthly precipitation, the interpolating process. Although contingent on the assumption of smooth transition between data points has demonstrated its practical utility in addressing data gaps, offering a reasonable solution within the given context. Working on this project together has helped us learn from each other and understand more about studying weather. By working on the Lagrange interpolating polynomial as a team, we have figured out how to fill in the missing data and why it is important to notice patterns in environmental info and how to pick the right methods for accurate results. This project has been like putting what we learn in class into real life situation and dealing with problems when some data is missing.
So for filler table, the fact is data on surface runoff must be collected before conducting any project at a particular location. So the idea is collect detailed data which precipitation fall within a specific time. And then the learning issue is how to collect rainfall data. So the action is we can get from Department of Irrigation and Drainage website. So number two is rain gauge at certain location of catchment area not functioning. So the idea in we need to obtain the missing data. Learning issue how to calculate the missing data. So the action is the missing data we can calculate by using Lagrange interpreting polynomial. So that's all. Thank you.